So Simon, it's 10 o'clock. So I stop this sharing.
Okay. Well, good morning, good afternoon, good evening, everybody. I'm Simon Baer. I'm at Stanford Synchrotron Radiation Light Source at SLAC National Accelerator Lab. I'm going to be moderating the discussion coming up. I'm on the executive committee of the International X-ray Absorption Spectroscopy Society. And this Q2XAFS presentation today is the result of a working group that has been in existence since the Q2XAFS meeting last year in Sydney. This is the first of a series of report outs by these working groups on topics that were deemed important enough to continue a discussion from the Q2XAFS meeting last year. So the presenter this morning is going to be Matt Newville. I'll let Matt introduce himself. But before that, the format is Matt is going to give a presentation talking about the results of this working group, and I'm sure he'll introduce the other members of the working group to you. Matt will occasionally pause for questions and discussion, but please use the chat function in Zoom to put down the questions as Matt is talking, and we can address those during the pause. And then at the end of the presentation, there will be ample time for discussion. And so during that discussion time, if you want to ask your question verbally, please just raise your hand using the function, or just type the question into chat, and we'll see how that goes. But without further ado, I'm going to turn this over to Matt Newville. Matt.
Okay, thanks, Simon, and hi, everyone. I'm going to try to share my screen. I think you can see this now. Hi, I'm Matt Newville. I work for the University of Chicago. We run beamlines at the Advanced Photon Source at APS, which is just coming back online. It's very exciting. I'm going to give you a report from the working group, as Simon mentioned, of the working on data formats for XAFS data. This has been a very active working group. We've been meeting monthly and discussing and traveling. I traveled to several sources in Europe to discuss this topic with many of the people on this group. The most active members were Wout, Marius, Mauro, Hitoshi, Abhijit, Shelley, Jerry, and Edmund, but there has been a host of people also listed there who have participated in the discussions or that I've talked to about this topic. So I'll also say that these slides and the example data that I hope to show and more other useful links and history are at this URL or this QR code if you want to grab this presentation and find more information that I'll discuss. So the report, or this report, is really the work of all of these people, and I'm just going to present some history and then like some recommendations we have for data formats. I think we've made good progress on getting multi-spectra files ready, or data sets ready to be shared. So just as a reminder, the motivation for this is that as the XAFS community, we want to be able to share XAFS data with each other and with this wider scientific community, including online databases, but also supplemental information and getting data into machine readable formats so that machine learning algorithms or extreme novices can use our data without having to be experts in the field. Also, at the same time, over the past decade or two, many facilities and funding agencies are or are working toward requiring that the data from the federally funded labs, so most X-ray beamlines, are readily available under fair data principles, so findable, accessible, interoperable, and reusable, meaning that the data that produced by the synchrotrons, at least most of the XF's data that we create, has to be made available. So getting a format that can be readily digested would be a wonderful thing. So the questions are, how can we best share XF spectra, maybe analysis results and so on, to the wider community, not just to the experts, but to even including the general public. And the history for this goes back a ways. So data formats were discussed even back at the first Q2XAFS, or the first thing called Q2XAFS in 2011. So Oyanagi-san created a working group then. Well, there was Bruce Ravel, James Huster, Armando Sole, Gerd Wollenruther, and myself to discuss recommend formats for XAFS. And we got to the point where we recommended an ASCII data file called the X-ray data interchange format, or XDI, which I'll talk about at length here. This is a plain ASCII format with really clear and well-defined keyword tags for a single XF spectra. And at the time, this was thought to be a big enough challenge. It was a challenge, in fact. But this is to get to a format other than the raw data from a beamline that can consistently show and describe an XF spectra. There were other options available at the time, like CIF, and we've decided that the plain ASCII format that we have is actually still quite attractive. But that only describes a single spectrum. And so more complex data sets, including handling multiple spectra measured at the same data run or even at the same time. The recommendation at the time was to work towards using HDF5 because that hierarchical data format can capture complex data sets, and it's widely used in synchrotrons. And I'll come back to this. Actually, what's maybe surprising is that was not more than 10 years ago. Those two recommendations are still the preferred options from our working group. So let me just give you a little bit of like a description of the XDI format. Probably most of you who are here have seen this, but I'm just to be clear, it's just a simple file with columns of numbers down here that are energy and I0 and so on, the kinds of data that we collect at the beamline. And then a header here with clearly tagged as not numbers with a clear delimiter, and then metadata broken into a family dot field and a value. So the mono despacing here and the beamline name here, that kind of stuff. So this is all actually we have now readers that can read this from multiple languages, and these are well used. And in fact, I'll say that at this point, these are pretty easy to both for a data creator, a beamline to make, and for any program to digest. Almost any program that deals with XF data can read those files. At the time, we also went through a pretty elaborate process of defining the names of things. So what we mean by, I transmission, what should you call that? Some people call it IT, some people call it I1. It's better if these names are, clearly stated. So we called it iTrans. And we mean iFluorescence, not IF and not iFlow, that kind of thing. And for XF data, at the time, either energy or angle for the monochromator was a reasonable thing to expect someone to write down. I would say at this point, please do not, I'm going to make this point a couple times, please do not use angle. We're communicating XF data, it's a function of energy. We also described at the time, though, a bunch of other column names for describing other parts of XF's analysis, like you might do a Fourier transform and want to describe that. I don't think anyone is really exchanging data that's already been Fourier transformed and using these tags in a way that's not specific to the program, the analysis program, or to the field or to the subfield they're in. I don't think anyone's exchanging these data and expecting people to read it across countries and so on. More details for this are at this website, where the code and all of the formal definitions are given. The metadata, we also discussed quite a bit at length. Metadata, so there's families and what they represent, and then fields inside of them, element symbol and element edge and mono despacing. And at the time, it was thought that these were really the required metadata and that everything else is sort of recommended. We have column labels like this. You can also put them in the line of the header, but in fact, it's good to have both and be able to read them, parse them more easily in both ways. So I'll say that XDI as a whole, several beamlines, including mine, but I've seen several others around the country, around the continents. So in Europe and in Canada and in the US, at least, using something like this. I might say XDI-like format that maybe not exactly following these family name rules exactly, but doing pretty good, and then they can be read in and mostly used by reliably by any analysis set of tools. So this is in reasonably well adopted and reasonably well used, but there's still there's strengths and weaknesses, but there's still some challenges that we need to address. So the principal strength is that this kind of file, an ASCII file with numbers, columns of numbers, and a header that's pretty clear, these are going to be around for 50 years. They're going to be useful for 50 years. And like, just to be clear, we're now at a point in the XFS world where data from 50 years ago can be looked at and said, is that data available and useful? And it turns out that data from the 70s and 80s is hard to use because of formatting. So there, you can look at the Farrell-Lytle database. That's data from mostly the 80s, but it's hard to use. It's not obvious how to read that in. You need an expert to read it in. Certainly a novice can't. But these files, we feel like that's an XF spectrum. It's energy and mu, and like someone will be able to read that data in if they want to. But it doesn't solve all the problems. It only represents one spectra. So for databases, supplemental material for journals, and for data sharing portals, we want to be able to show multiple spectra, perhaps hundreds, maybe thousands of spectra. We want to make the data much more easily digestible for machine learning algorithms or non-experts, including whether you do dead time corrections, how those are done, and so forth. One of the challenges of, especially for data collected with multi-element detectors and fluorescence, is that there's both raw data that's fairly huge, many columns of numbers, but then you want to digest it into this one single set of one single value of mu, and how to do that math. It's not hard, but it's also not trivial. And so you want the more raw data available for the experts, but you want to present something that is like clearly, this is what I mean by the XFS. And it's also, as we're doing this, we're also thinking about extending how we can extend this to include emission data or XRD patterns into either the same data stream or into the same kinds of formats. And so some XFs like spectroscopies, certainly HRFD, maybe full field XFs, maybe X-ray emission, maybe resonant emission. We're thinking about how we can include those in these kinds of data formats. And we also we want to include that also in all of this theoretical both results and inputs in the same kinds of formats so that we can read those in with the same tools. So XDI is a good start for all of this, but we need something more, and getting something that's both more and going to be useful for 50 years is a bit of a challenge. So I'm going to give but there is a clear and maybe clear, but like not without weaknesses, candidate for how to store multiple spectra, and that's HDF5. This is a container that can handle multiple spectra. And even in 2012, for the paper that Bruce was the lead author on, HDF5 was recommended for more complex data sets. It's widely used in synchrotrons and other scientific fields for large data, and I mean hundreds of gigabytes. It's very efficient at storing large numerical data sets. So if you have a 3D volume from tomography, it's very good at compressing that. And it's it's pretty well supported in many programming languages. And it uses a simple hierarchy. So it uses like a file system hierarchy. So a file system has folders or directories and files and folders inside the other folders, so subfolders and subgroups. And this uses the same concepts. It has groups that store data sets and other groups. So you get a simple tree-like data structure, very, very familiar and very easy to navigate. Not necessarily the only option, but very easy to deal with. HDF5, though, is not without criticism, and these are important things to recognize. The binary format can only be read with its own library. So yeah, once you start using HDF5, you're stuck with using HDF5, and there's not really you're stuck with its tools. It's not great at having multiple processes read and write at the same time. And if you try to do that, the files can be corrupted. And by corrupted, I mean not recoverable. So when we use HDF5 at synchrotrons, we typically have a backup of those. And so we'll continue in this discussion to promote XDI as an alternative for single XAF spectra, but having HDF5 is important for performance and for efficiencies, but you need a backup. And at this time, I'll say HDF5 is really the only one that's really worth considering for experimental data with large arrays. There are other possibilities, but when you look into those, they all have weaknesses, important and maybe even fatal weaknesses too. So that's an important consideration. So HDF5 is what we're going to use because everyone else is using it. Not that it's bad, but we are stuck with it, but it's not bad. I guess is how I would put that. However, like this is just like HDF5 just gives you structure. It's just this groups with data set. It has no meaning. It has no like layout that's predefined. There is an effort that's been going on for actually more than 20 years called Nexus, which is neutron and X-ray something. Neutron and X-ray. And that tries to give meaning to, or layouts, or what we call schema to different categories of data. And this is also used widely at synchrotrons. Actually, it was developed at synchrotrons and neutron sources, especially for scattering and diffraction data. Nexus is community-led, and there's an effort to define and support and validate schema or definitions for different kinds of scientific data. So we need a Nexus format, a Nexus schema for XAFs. Actually, I'll say there is one. It's really bad. What we're really doing is redefining that one. Nexus has some other interesting properties to it. Many facilities, especially in Europe, are now mandating or thinking about mandating Nexus as the data it presents in its fair data portals. So we're definitely going to be using HDF5. I'm willing to hear criticisms, and we're definitely going to be using Nexus. I'm willing to hear criticism, but that's going to happen. So we just need to we just need to catch up and accept this and use it. So we need to work on. So what our working group needed to decide was that first we need to do this, and then we need to work on the definition for what we call NXXAS, the Nexus definition for XAFs. It turns out that one of the people in our working group, is on the committee that helps decide and accept these proposals for Nexus. So that's really great. And they need help from the people who do that are, format and synchrotron people. They're not necessarily the spectroscopists. So they need input from domain scientists or the people doing different techniques. That's us. So we're in this conversation with the Nexus groups to make a format that fits their needs, their conventions, and also what we have both in XDI and what we need as a community. So key goals of our working group were to identify the key data. What is the data we want to share? And what is the metadata we need for communicating XAFs? And then refine or make up a new definition, and then make sure that we can still continue to map this new format, NXXAS, to and from XDI so that they're easily exchangeable. And then we also need to develop examples and translation tools from Nexus to XDI. So actually, if there are questions, this is a fine time to so those are our decisions on what are the important things for formatting to do. I can continue, but if there are any questions, I'd be happy to give a slight pause here.
There are no questions in the chat.
Okay. Okay. Great.
As of now, Matt.
Okay. So
but just people that have joined late, maybe I'll just. Oh, sorry. people that have
Sure.
joined late, please feel free to enter questions into the chat function as Matt is talking. Thank you.
Thanks. Yeah, I'll say, okay, so that was all like preface of like what our charge, what we interpreted our charge to be. I think those things can be questioned. But those were what we did. That's what our decisions were. So XDI specifies many options for data, like I-trans, mu fluorescence, and can support multiple of these. So like a reference channel, if it's measured at the same time. This is okay, but and XDI is good, but it's also not great at multi-element fluorescence data. So if you have a 10 or 100 element detector, XDI is kind of clunky because you got a lot of columns in a file and it gets kind of hard to use. Separately, Nexus really wants a single main data set. It wants something called intensity. So partly, this is so that it knows what to plot. Just like, show me this data set, what do I plot? I'm going to plot intensity. And it thinks, well, maybe it's 2D or like 3D data, so it's going to print up an image, or maybe it's single spectra, so it's going to plot, make an XY plot. So we kind of want to get to the point, if we're going to use Nexus, of defining what this one data set is. I mean, Nexus also allows a host of like other data, so you can put in many multidimensional arrays, but we need to define this one data set. And that became interesting because this is something that we had sort of punted on, we'd skipped over in the XDI definition. And the question of what is the XAFS data that we want to share with people a decade from now, a continent away, including non-experts who are reading supplemental information from a paper that was published 5 years ago, and they see the supplemental, they go download it. What should they be seeing? And what should a machine learning algorithm like be getting as, I want to go look up XAFS data, what should it get? So the answer is kind of obvious, but it's also like an answer that's not in the raw data stream. And that is, we want to present as XAFS the pre-edge subtracted edge step normalized mu of E. This was the decision of the group. I'm in favor. I'm in favor of this, but like this, so this requires some light processing of the raw data, of the so-called raw data. It's like, nicely, I think, in my opinion, this skips over the question that the beamline scientists in the group will know they get from users all the time. Do I use IF over I0, or do I use minus log of IT over I0? And it's really easy to make that mistake as a novice, or even as a journeyman XAFS person. And this does that. This says this is going to be done as you present the data. It's also, I'll say, like, for the people who are hesitant about this, that this is easily described. Pre-edge subtracted edge normalized is subtracting a line event in energy and then dividing by a single value. So that's easily undone or redone, and no one is going to say that this is going to be the perfect way to do this. It's just going to be very close, maybe only close for some data sets that are hard to do, because sometimes this process is challenging to get perfect. So maybe it's easily undone and easily redone, so not so bad. It also encourages, like, for fluorescence detectors, you do the dead time corrections. You do, so you do input count rate over output count rate over however you do it, and do the sum of the fluorescence channels. So that should be the other sum. For data in multiple modes, so for several beamlines, they collect both the transmission and either the fluorescence at the same time, or they'll collect a reference spectra simultaneously in the same measurement. And this idea of having a single data set does not support that, but Nexus does support having either subgroups or links to other groups. So you can have a subgroup if it's the same, if there's a reference channel in the same spectra, in the same scan, or you could have a link to the iron foil if you have 100 iron spectra and one foil spectra measured, every 10 minutes or every day, or however you do it at your beamline for energy calibration. So Nexus actually supports both of these, but it's still only one spectra per group, which I'll get to. So that's the data. We want intensity to be normalized mu. And then a bunch of other stuff that could be anything you want. XDI specifies many optional pieces of metadata, and a simple way to organize it. Nexus allows a really rich and hierarchical metadata, so you can imagine lots and lots of discussion and rehashing of ideas of what could be done, what metadata is needed, what's formal, what do we want, and nicely, I think our group, like I hesitate to credit who really brought this up, but at some point we just said, okay, wait, what do we really need? What's the minimal thing we need? And so we got to the point where we got to what is required or strongly recommended metadata. And it is like, what do you need? You handed a spectra from a facility that you don't work at that was taken 5 years ago. What do you need to interpret that spectra? And you need the element and the edge. And everything else is kind of helpful, but not necessary. It's nice to have a name of a sample, but the name could be something like sample 3, or it could be FEO. And when someone says FEO, some people say, great, I know what that means. And other people say, wait, that's a whole topic of discussion. So, and that's fine, but the sample got named something when it was collected. It's nice to have the name of the laboratory facility or the beamline used. That's almost vital too, just so you have a sense of calibration and resolution. The date is helpful, and the name of the person uploading or collecting or responsible for this data is good. The measurement mode is very helpful, but since we already have normalized edge step normalized data, it's helpful, but it's not super important. It's just helpful. So measurement mode is good to have. And then the monochromator despacing, if you're using a double crystal monochromator, or crystal cut, if you're using a double crystal monochromator, are really helpful so the energy can be recalibrated with high accuracy. Despacing preferred, crystal cut okay, nothing acceptable is acceptable. So I would say like element and edge are required and everything else is strongly recommended. So also like just in this category, it's great to tell us what the coding of your harmonic rejection mirror was. And some of us care about that. Structured is good, but we just didn't feel like we could like really make a comprehensive dictionary of how to spell all of those options. Okay, so to recap, data, 2 arrays, energy and intensity, pre-edge, subtracted, normalized, and then you can allow for multi-dimensional data. Include a description of how you did that. And I'll show you some examples. And then metadata, there's this stuff, and that it sort of fell off, but this can support laboratory data and theoretical XFs as well. At least in principle, we can support those without too much effort, or without too much trouble. Laboratory XFs and theoretical spectra could be handled. Okay, so Nexus, the format for Nexus then has a layout, and it looks like this. There's a definition that is NXXAS. There's an element, there's an absorption edge, there's a measurement mode, there's an energy array, there's an intensity. This follows XDI closely, but it's not perfect and one-to-one. What's sort of, there's a reference that could be a name or a link to another group for a reference spectra. And then there's raw data tables. And then there's also a process, which is just a list of strings that tell you how you did the processing. And then with the formal definitions of instruments already existing in Nexus, the way you would get to the monochromator despacing is this way. You would they already have the concept of a monochromator and the despacing and the crystal name. So we're just using those. And then the standard lookup tools can be used for getting all of that metadata. And the rest of the metadata can just go into other headers that are available in the scan and aren't listed here, but there's a huge list of things that are available. This is sort of the minimal set. Okay, so here's an important part of this though. Many beamlines, including mine, are already saving something into something that I like XDI like. And some people are already saved data to HDF5. This is great. But no beamline or facility is saving data into this lightly processed normalized formula or data format that we're proposing to do. So we all need tools to help do this. So we need to write tools to help you all at the beamlines and in the XAFS groups around the world do these conversions. So we, meaning Wout, has already started this. So we have a project XAFS. Here's the GitHub repository. These are tools. These are Python code to convert between NXXAS and the new style XDI, matching the NXXAS exactly, and convert existing data files from sources into either format. So we are willing to help write converters for your beamline, and we would love help also making these tools. And I'll show you a demo. Actually, this is a good time to pause for questions too. I'll pause for a demo here for to show both of these examples.
So Matt, should I read a few of the questions that have come in the chat?
Sure.
Okay. So I'm going to read out the name of the person, and then that person wants to add more comments. Please go ahead. So Maria Chan said, should we include the post-processing code with the data?
Yeah, I'll show an example of that. I'll show how we do or one way we did that.
Yeah, this was more when you had the slide about the data included in the paper and how they relate to the raw data. And I think if we sort of include the code that turns one into the other, then it will be unambiguous.
Yeah. Nexus struggles. I'll say like everyone struggles with this like in detail, but yeah, Nexus has some concepts for that, and we'll show you, especially for the light processing. I think it's doable to be in a way that like could stand the test of time, right? So I'll show you. I'll try to remember to show you that in the upcoming. Yeah. Thanks, Maria.
And then Masashi Ishii wrote, can you give us your thoughts on the description of metadata related to sample names, especially the unification of sample names, which is necessary for machine learning?
Yeah, that's a great question. I think that's something that, okay. I think that's something that maybe we need to work on as a separate or as maybe the next step, partly because I think it's field dependent. In the area of data that I collect the most often, sample names mean very different things than biologists would interpret. So people use oppo in my field, and that means something totally different to a biologist. And so I think that short of like requiring that everyone put in, a CAS number, which is not actually practical because like those don't exist. Like, you're taking data on samples, right? We take data on mud, right? So, there's no CAS number. So short of that, it's hard, but I totally appreciate that like that's important to figure out how to make standardizable. But I also think that like we're not the only ones to need that, because that's not about excess. That's also about like if you're doing SACs, you want to do this or TEM, you might have the same issues. So but it would be helpful for that to get solved. I think yeah.
Yeah, of course, it is very quite difficult thing, but now we are making some material dictionary. What do you think of that kind of dictionary publication in this working group?
I think that having a dictionary of the kind that like you presented to our group, like I think that that's very useful to say, here's a guideline of what we want to call things. But I also think that we wouldn't want, I think we could say that we want to have a pre-processing or a validator. Like if you're uploading this XF spectra and it doesn't have the element name in it, or you can't tell what edge it was, that's a problem. But if you can't tell what the sample CAS number was, maybe that's something that we just say, do you have that? Because again, some people won't. Right. Yeah.
Okay. Thank you.
Then I actually have a question, Matt. Regarding the reference channel, is this something you is a must, or is this a strongly recommended? Did you address that?
Yeah, right. This is complicated because I might say it's strong. It's a recommended, right? I didn't put it in the recommended. I might say it's a recommended, but it's sometimes challenging to. Well, it's challenging to know that it's been measured well for any spectra, because it may have been measured like the day before, and that's still valid, but the day before might mean that it's invalid. So it is kind of like there is some context. So it'd be nice to be able to specify what the reference you're using is, even if it's a different edge. So then that gets complicated too, right? So we do a lot of work on uranium, and yttrium is many people do this, or they'll say we measured the iron foil or the copper foil, and then we did a bunch of cobalt measurements, and we know it's good, but that's what we did. And so I think we could include that in strongly recommended, allowing for that level of complication. Does that seem okay to you?
Oh, yeah, for sure. Absolutely. We all know the complications there, I think. And then Donato has written in, what about other information such as temperatures, gas flows, voltages? Should they also be included in the metadata?
Yeah, I would say the same. Like that's even more that's sort of the same answer as the sample names or the sample descriptions. Like some people like they just don't like there's no voltage applied. So like trying to require voltage. But it would be great if we had a dictionary that said, here's how we want you to spell those things. Here and in fact, Nexus has a lot of that already existing. So we can assemble those well, I think. But we haven't done that yet.
I think we should pause there and let you continue. Thanks, Matt.
Yeah. Okay. So let me see if I can escape this and go to. You're still seeing this, and now okay. So this is a viewer. I've done a few examples just to show what these files look like. So here's a set. Here's a Nexus file that we created from a few of the classic, kind of foil spectra sample. This is using the viewer from ESRF, the Silix viewer. And so this single HDF5 Nexus file contains 3 spectra. Here's iron or hematite and iron metal and FeO. So you can see that like just clicking on that in this viewer shows the normalized edge depth, normalized mu of E. So that's super convenient. And that's a function, like this viewer knows to do that because Nexus tells it that that's something to do. So this file or this group has an absorption edge, a definition is XAS, an element, it's got an energy array and an intensity array. It's got this instrument that's like a bunch of hierarchical things that were found, like in here, source is APS and the energy, the monochromator has a crystal and a D-spacing and all this kind of stuff. So this is all hierarchical and easily digested from an existing HDF5 file. And then there's a raw data table that's like, this has only 3 columns and column versus, and then somewhere in here, there's an attribute that lists what those are labeled. The reference here is none because this was not measured with a reference spectra at the same time, although these were collected together. And then there's a title, FE203 from the APS. What else? Oh, right. And so Maria, so in here, there's a group for process. So here, this has a date that it was processed and a program that was used in a version, and then notes. Here, it's just the text. And this is just like sort of simple Python-y text for like what the calculation was. That's where the, like, we did that edge step and that pre-edge. And then we, in the intensity is this column, this mu is ith log of trends over I0 defined by this from the data set. So that it's pretty reproducible or pretty easy for a human to read that and be able to undo. Let me also bring in another one of these that so this is data from the Photon Factory that is, again, that's the data. This data was collected. The raw data here was actually a function of angle. So the raw data file, if I find that, was a function of angle, which is maybe unfortunate, but that up. Sorry for what making you. This raw data file here is angle and intensities. So that data set was turned into this, which has a plot of like that. Again, okay, so that's that data set. And then one last example. I don't want to belabor this. Here's multi-element fluorescence data and a bunch of spectra that were collected for vanadium zanes. And there's, I don't know, what, 12 samples or something. And here, this is multi-channel XS for, so that this had, this had multi-columns and a dead time correction done during the processing to get to this plot for this data set. And some of this, and this is like maybe what you might expect. Some of the data here are kind of noisy and there's multiple ones and there's a little bit of variation, but you can quickly browse through that. I'm going to pause here. Are there any questions? So this is a quick view of like those files turning into both this new style XDI or like our XDI and this Nexus format. Are there any questions here on these sort of, this layout or this kind of view for these data sets?
No questions in the chat as yet.
Okay.
Anybody want to ask live briefly? Donato, would Nexus also include 2D XAFS maps?
So I would say that we might want a separate Nexus definition for that. That's worth discussing. There's definitely a call, like separately, we do X-ray fluorescence and X-ray fluorescence mapping. It might be one, and trying to get a Nexus definition for that is also like interesting. And I've talked with some of the people there with the other Nexus people who are interested in a similar topics like STXM and so on. And there is one for STXM and whether that can be applied for X-ray fluorescence mapping and whether that can be applied to X-ray absorption mapping is interesting. And then like Rick's plane is slightly different, right? So handling 2D data sets is worth considering how to do that well. We sort of thought in this group that this, so single, one-dimensional, would be useful for, this could be extended to like XMCD, that's 2 arrays, right? And XES, that's like just going the other way, and maybe a few other any other variation on XAS, but XMCD and XES are 2 that this could be modified to accommodate. And for 2D XAS, for full field XAS, maybe that's a separate definition, but maybe it's also like a separate definition that's very, very similar to this, like just replace intensity with an energy with a map, right? A spatial map and an energy and then a 3D map of X, Y, and mu.
And then
But with the
theoretically,
same
last question.
Mhm.
What about QuickXAFs with multiple scans?
Well, each one of those is fine to put into a spectrum, and whether that's a question for your fair data portal policies. Does each scan get written as data, or are you already summing them into some suite? You could, if you want, to present those as a bunch of columns in a single file. There's one energy, and then you ran those into a single, and then add those up. You could do that, but that's sort of a question of what you call your data. So in fact, I should be clear that in all of these discussions, yeah, go ahead.
I was going to clarify the question. My point
Sure.
was more, for example, you collect 10 minutes of QuickXAFs with a Fram monochromator where you got multiple scans up and down, up and down, up and down. And usually before you give it to the user, or at least you give the user the tool to process those data in order to give them separate scan. In the Nexus, should they appear as one single continuous multiple scan for the whole 10 minutes you are collecting, or should they appear as, for example, in your first example on the iron, each single scan as separate?
Yeah. So so I'll say this. So here, this energy array should be one-dimensional, and the intensity should be one-dimensional. The raw data, you can kind of do whatever you want, and then you just expect to be able to describe the processing. So if you want to include that raw data as having 8 million X points, and then you interpolate those two energies and combine them and bin those however you want. If you can describe that in a way that you think people could reproduce, that's fine. On the other hand, if you prefer to take that, raw data, all data is not quite raw, right? So if you want to take what you're calling your raw data or as collected data, then you can process that already ahead of time. So I think that's kind of up to the beamline. And that would be similar. There'd be a similar response for dispersive XAFs, right? If you're measuring dispersive XAFs or full field or with a Fram monochromator, how you turn that into energy and mu is kind of up to the beamline. I'll say the same actually for fluorescence XAF. So most people who collect fluorescence XAFs with a multi-element detector are collecting single binned ROIs and calling that, iron K alpha from MCA1. But that's not necessary. You could collect the full XRF spectra at each point, do a fit, and extract that later. And if you want to include all of that data into a single spectrum and then have it be complicated, you can. Actually, the raw data here, you can have multiple raw data sets. You don't need, you're not restricted to one. So if you want to have images that you extract if you're doing HRFD and you're using an area detector to extract your signal, you can put the images into those files if you want. It gets big, but you can do it.
So Matt, there are several more questions. I was wondering whether we should have you go ahead and then have the questions for the discussion towards the end.
I'm okay with that
because
I'm okay with that because let me go back to right. I'm okay with that because let's see, I do view and I do full. I have a few more slides. Let's see, that's it. Okay, so a few more slides on databases because this topic also sort of covers databases. And the working group has not done much on it because we felt like we need to get this done before we're ready for databases. There are a few public online databases. Here's a couple and my own take on them. There's the one in Japan. There's an X-ray lib absorption, which has the URL wrong, but that's only a couple hundred spectrum, but it could be improved. Happy to do that. There's a very nice one at Canadian Light Source, and the shade one at the FAME beam one is great. These are all very good. Most of these aim to have curated XAFs data on well-known standards or good data on good standards. And there's also these data portals like Data at ESRF for uncurated experimental data. Okay. And so some discussion points like, okay, sharing pre-edge subtracted normalized mu, again, like that means you have to do some light processing. For some beamlines, that might be more than light, but it's also probably what you're already doing at those beamlines using from monochrometers or HRFD and area detectors to produce something that looks like an XF spectra anyway. And the raw data can be included. We have a truly minimal data set of recommended metadata, and we think these formats can be extended to, related spectroscopies with a minimal amount of work. And we all need translation tools, and this work has begun. Okay, so and then there's other real challenges. How do we encourage the adoption of this? And most that's one important question that I don't know the answer to. And then many online databases use XDI or something like it, but some don't. And so what do we need? And also, like, just a related final question, do we actually want, as a community, a centralized online database? Okay, those are all my questions. Those are the big topics of discussion that we could go on for, I'm sure, hours about. So let me put that back here and go back to like this possibility of somebody asking about like this format too. So happy to take any questions and have more discussion.
First of all, thank you, Matt. Thank you for this working group. Clearly, you put a huge amount of work and effort into this, and I think the community really appreciates this. So with that, let's see what's in the chat already. Santiago, do you want to ask your question, or should I read it out? Maybe you can't hear. Santiago said, what is the reason for not fully normalize the data with the post edge? Oh,
I think, so this is subtract a line and pick an edge step and get it to go to 1. And partly that's because, well, that's what like theoretical spectra would look like. And if you're going to do Zane's analysis, this is a really good like place to start. But so also say any analysis is going to do this step. So getting this to be what you present, and you can like plot things over each other and so on, and things look, reasonably like right. I think this is a fine way to say this is what we can do, and it's very, very simple to do and undo. I think I hope that answers the question. If not, let me know.
Simo, do you want to ask your question, or should I read it out? Okay, Simo, in X-ray Raman or RIX-NIX techniques, there is also momentum transfer scattering angle associated with each spectrum. Can it be added as a keyword for each 1D or 2D map? And how about crystal orientation with respect to polarization vector or scattering vector?
Right. Those are yeah. So I think that extending this to include momentum transfer would be not hard. To say that you have multiple spectra at different Q values in a single file, I think that might break what Nexus wants. So I think that might be either a collection of these or a separate definition. And I think so. There might be already some work on RIX, especially like the low energy RIX stuff in Nexus. So I'm not sure. So I think that's quite possible to think of that as an extension for handling polarization. I would put that in the same category as temperature. Like, yeah, that's a really important thing to know sometimes, or maybe even like more often than normal. We normally have it. So being able to say which orientations were available, and that can totally go into the sample. I believe that some of the magnetic scattering definitions already have that built in, so we can just like lift there. Like sample could be, orientation, and the instrument can have a polarization vector. Those are sort of supported in regular Nexus or regular Nexus, other Nexus definitions.
Okay, next one, Konstantin. For post data processing, what are your thoughts on updating existing Nexus fields in the same file versus creating a new Nexus file, maybe linked to the raw data?
Yeah, so I'll defer to Wout and the people at ESRF on this who think about this a lot more than I have done in the past. That's a good question. I think I might suggest that, okay, so this is, if you do processing on one of these groups, do you want to write it over, like overwrite this group, or write it someplace else? I might say that you could have that be a subgroup of these, but I'm also willing to say that I don't know that that's the best workflow. So all those are actually possible, which is nice. Links, yeah. So as I'm sure you know, Constantine, like links that are external can break. So internal links are better and subgroups are good, but yeah.
And then Adam Clark, what's the timeline for having an accepted, updated NXXAS definition?
Thank you for that question. So I believe that so this is sort of like there's some politics involved in that. I believe we have a definition that now the XFs community can say, we worked on this and this is what we want to the Nexus people. And Wout is on the Nexus International Advisory Committee that accepts these. I've discussed this with those people and I know some of them. So this is not like out of the question, but it might still be a couple of months, or it might be, a couple more months. I hope that's, I hope Adam got all of this is recorded, right? Yeah, I think it's doable. I think everyone in the conversation is in agreement that this is important and that none of this is like absurd to do. I'll say,
question,
if I can briefly
yeah, go ahead.
It's of interest to me presently whilst building the new beamline and defining our data acquisition chain. Could you also share what your current definition is, so I can potentially see how that fits in with?
Yeah. So you can send me or Wout an email, or we have a pull request that is currently in progress. Yeah. Sorry.
Thanks, Adam. Let's see, what's this one? For the case of double or multiple edge XAFs fitting for one sample, much like an iron nickel alloy, can we use metadata set to achieve the constraint during the fitting because of two data for the same sample?
That's I'm not sure. That's a great question. I think so. Okay, so this might come back to, it would be, so I think to do that, I'll be honest, I think to do a double edge, a fit of two edges simultaneously, and knowing that the sample is the same, you really need to have a lot of process knowledge, as we might say in DOE speak, that that the sample was the same, and expressing that in a file that you expect someone else in a different continent 2 decades from now to be able to know is tough. But like the person who takes the data, or even like the person who like took the data and then gives it to their person and gives it to a person, so a friend of a friend of a friend, it might work to say this, because this one file has those two groups in it and they were taken at the same time at the same beamline, you can detect that, and the sample name is the same. You can infer that, but like, yeah. So that I think, so whoever, that's a tough question. That's tough to do. I hope that's a sufficient answer.
And then getting on to databases, are we planning to have a single database portal for users to compare data between different light sources, beamlines, and techniques that are conventional?
So, okay, thank you for that. Thank you for that question. So I alluded to this, and this is sort of separate, and then this, I'm not talking on behalf of the working group, I'm talking as me. for this. There are all these great data portals available. Pretty much all of them are tied to a single facility or a single country, a couple facilities. And it would be nice for the International XAFS Society or the IUCR Commission on XAFS to have a portal that was accepted, standard, international, followed all the conventions, and was available for everyone, and had data taken from those different sources and sort of curated, or maybe even like, maintained and vetted in some ways. XASlib, X-ray-absorption.org. I wrote that. I'm going to say, and that was my intention to make that happen. And then we realized that like there's all this trouble of like, do you have the right to take the data? Who is going to like claim they curated it? I would be, again, speaking as myself, I would love to see that. I would love to see someone take that up. I think it'd be nice to get buy-in or a request from either the IXAS Executive Committee or the IUCR Commission to say, we're going to do this, and we can take some of the data. We know we're allowed to, with like the licenses available, and it's okay. And we can, give references to the original sources and the DOIs that are available and so on. So making that place better. And I'm just going to say, like, I know that one, XASlib, could do this. I feel like it could be done. And I think maybe, in my personal opinion, it should be done, but it'd be nice to get actual community direction on this and clarity. So I think that's a question that I would like to see the answer to over the next, months, maybe a year or so. Like, should that happen? And from every point of view, the technical part, I think, is possible. The legal part, I think, is possible. But is this a good idea? Will people be offended?
Yeah, I think this is an important point. I mean, we face this all the time, almost on a daily basis. And I think I would like to think that this is a discussion, certainly, that's highlighted at next year's Q2XAFS meeting, which is going to be run as a satellite to the International X-ray Absorption Spectroscopy Conference, and maybe even a topic, there's some sort of panel discussion at the actual conference itself. For those that perhaps couldn't attend the satellite meeting. But I think I'm going to defer to Kiyotaka here and say maybe that's something that the committee should take up for sure.
Yeah, we are going to discuss this point, this next Q2XAFS. And also, I think Ishii-san has some comments on this point.
Yeah, okay, so I shortly talk about that. So maybe Hitoshi comment about that. So now we are making some XAFS database portal. So maybe it is one of the solution for the integration with the database. So we will discuss next year in Q2XAFS.
Thank you.
Okay, there are no further questions in the chat, Matt.
Can I ask one last question?
Oh, of course, go ahead.
What about the sizes of the files? Like we were talking earlier about fluorescence data, and if you go, for example, a 36 element detector, you got 36 MCA for each detector, and all those data. Will there be a limit on the file size for portability / readability purpose, or is the file as big as it needed to be?
So my view on that is that XAFS is always XAFS is always on the small side compared to synchrotron data, and what Nexus can handle, no problem. What a data portal can handle, not really a problem. I'm going to say for 100, let's just go to 100 element detector. If you're saving ROIs, that's fine. I think maybe some of your beamlines, but my beamline, we collect X-ray fluorescence maps where we collect a map that's 1,000 by 1,000 pixels, maybe not today. Someday soon, we'll be doing this again. 1,000 by 1,000 pixels and 7-element detector, 4096 energy points. We're saving all of that data into a file, and we collect those at 3 millisecond dwell times. And that still pales in comparison to our friends over at the next beamline who do tomography. So we don't even worry about that. We worry about the tomography. That's really a problem because that's terabytes of data per hour. That's hard to get like across the network. Whereas, so I think no, but I could be, maybe I'll say, okay, that's also like coming from the point of view of someone who works at a federally funded lab in the West. So, maybe we're thinking that like, this is no problem, right? I'm giving this talk from my home with, not worrying about download speeds at all, right? Like, so it might be something to consider, but I think that it's not, I don't think we're driving a problem with that. Do you agree?
Well, yes, of course. There are compared to tomography, we are pitfall in terms of data. But when you start to add with evolution, with mapping, QuickXAFS, multiple element detector, you could soon reach not the size of a tomography scan, of course, but
yeah,
you increase in size and read more than portability is more than readability. How long will the software will take to process all the data, all the search and everything? It is more about the post-processing part.
Right. Yeah, so handle like reading the data, like so with Nexus and HDF5, drilling down and finding some piece of data in 100 gigabyte file is actually very good at that. That's what it's really good at. But right, if you need to reprocess that data, that's harder. And also say like that we're talking about, so data size is not a problem to the reading. It can be a problem for storage, and it can also be a problem for like submitting as supplemental information, because the journals want raw data, but they don't want too much. They sort of want the data that went into the figures in the paper, it seems like. And so I think there's a balancing act. You might need to do some reduction of that. But like you could imagine that you take one of these HDF or these Nexus groups that are HDF5, and you just take out the raw data, like just delete that, and then upload that to the journal. And they say, here's the data. And if you want a link to the raw data, here's a link to our FAIR data portal, and you can get all the raw data you want. So I think those are all like possible. I hope that's, yeah.
No, it's perfectly fine. Thank you for the answer. Thank you for the talk.
Yeah, thanks. Okay.
Any other topics for discussion? Okay, well, in that case, I'd like to thank everyone for participating. I think Matt and this team, this working group, has done a fantastic job of pulling this together. I know there'll be discussion next year as well. But with that, I think we can close this meeting. Kiyotaka, do you want to say anything?
Yeah, thank you, Matt, and thank you, Simon. So I want to make an advertisement of next Q2XAFS meeting. It will be held next. Oh, can you see? Oh, yeah. Next one will be held. August 9th.